Alrighty guys, so today we are going to work on part 1 of our review. Again, I am working on SAT stuff today, so I will not be in Zoom, but you can use this video to work through your Unit 2 review. Alright, it's going to be a we do, I do setup, so for today alone, we're going to go through the odd problems together. Okay, I'm going to post an assignment that coincides with this so that you can put your answers for the odd I do's and then get that feedback. And then Thursday when I get back, we'll do the evens together and then address any questions before our test on Friday. Okay, so getting started, we're going to start on number 1. Okay, again, we're just doing the odds together today. So we need to write an equation of a line that passes through point Z and is perpendicular, okay, keyword perpendicular, to the line y equals negative 1/8 x plus 2. Right, remember perpendicular lines have an opposite reciprocal slope. Okay, so that means that we have to take this slope given here, flip it, and change our sign. So in this case, our perpendicular slope has to be a positive 8 because again, I am flipping this 1/8 into a whole number and then changing my sign to a negative. Alright, since I am writing an equation, I have to use my point slope because I'm given a point and a slope. Alright, so point slope form here. All I do is substitute in, so y minus my y1, which is negative 8, equals m, we determined is a positive 8, and then x minus 4. Okay, so this is our equation in point slope form. I'm going to go ahead and change this double negative into a positive. Right, to get this into slope intercept, remember we have to distribute, giving us y plus 8 equals 8x minus 32. And then last step, get our y by itself, making our equation 8x minus 40. Okay, so this line, if we were to graph it in a calculator or on Desmos, these two lines would be perpendicular to one another. Okay, moving to number 3. Okay, in the diagram below, measure angle 7 is 55 degrees. Okay, so find the angle of measure angle 1 to prove that A and B are parallel. Okay, so think about our angle relationships. Okay, so we have this exterior angle on the outside of our transversal and parallels. All right, it's 55 degrees. We know that alternate exterior angles, okay, so 7 and 2 would be congruent. Okay, so make a note of that. 7 and 2 have to be congruent, making 2 55 degrees as well. Okay, and then thinking about how 1 and 2 relate, okay, you might notice that they make a straight line. Since these are consecutive, they are going to be supplementary. Right, 1 and 2 are supplementary, so they have to add to 180. Okay, so if angle 1, we'll do this in pink. So the measure of angle 1 plus 55 degrees, which I'm talking about the 2 here, is equal to 180. Then I know that the measure of angle 1, when I subtract this 55, gives me 125. Okay, so measure of angle 1 is going to be 125 degrees. So it's safe to say that 1 and 7 are supplementary. Okay, moving on to number 5. Okay, so the point R is contained in the line that is parallel to line y equals 5x. Write an equation that represents line M. So if you're reading over this and you're like, holy moly, what is going on? Remember, you can always draw a picture. So we have the point R, which will be pink, right? So R right here is contained on the line M. So we'll do M as a blue line. Okay. It's also parallel to this given line, right? So this is, we'll just call this L. Okay, so this is y equals 5x. Write an equation that represents line M, or in this case, our blue line, all right? So remember, if it is parallel, parallel lines have the same slope, okay? So we need to write our parallel slope, which in relation to our purple given line, L, is a slope of 5. So if these two lines are parallel, our slope for line M has to be 5 as well. All right, then remember we're given point R, which is 0, 3. So think back when we're given a point and a slope, when we need to write an equation, we use point slope form. So y minus y1, x minus x1, okay? So I'm going to substitute in for my information. So y minus, all right, I'm going to take the y1 from my point R equals, we determined our slope is 5 because it is parallel to the purple line, and then x minus my x1, which is 0. Okay, so if you're not sure where I got those points, just remember 0 and 3 come from point R, which is right here on line M, and then our blue slope of 5 comes from this line that it is parallel to. All right, so this is our equation in point slope form. In order to get it into slope intercept form, we distribute. So y minus 3 equals 5x. Okay, and then last step, get our y by itself. So we're left with 5x plus 3. Alrighty, moving on to number 7. Graph the following lines and describe them. Okay, so these lines are in slope-intercept form. All right, since they're in slope-intercept form, we know that the number in front of our x is our slope, and then our b is our y-intercept. So I'm going to do my two lines in different colors. So I have my pink line, which I'm going to graph first. We have positive 5 as our y-intercept, and then our slope is a negative 2, 3, so down 1, 2 over 3, down 1, 2 over 3, all right? And then I'll do one more for good measure. Okay, so our pink line looks something like this. All right, and now we're going to do a purple line. Okay, so start with your y-intercept. We have a negative 2 as our y-intercept. And then we have a slope of positive 3 over 2. 1, 2, 3 over 2. Up 3 over 2, and then up 3 more over 2. Okay, so if we're looking at our pink and purple lines, it should look something like this. And then take a second and look at your slopes. Okay, so we have a negative 2/3, and then we also have 3 over 2. Okay. Remember, anytime we have a slope that is the opposite, so this one's negative, this one's positive, a reciprocal, so these are actually the flipped versions of one another, these lines are going to be perpendicular. Okay, and one more way that you can check if they are in fact perpendicular is multiply your slopes together. Okay, if you multiply straight across, we get a negative 6 over 6, leaving us with an answer of negative 1. Remember we went over if you have perpendicular lines, the product of their slopes. So when you multiply the slopes together, you should get an answer of -1. Okay? Now on to number 9. How do we prove that these two lines are parallel? Okay, so this is very similar to the graphing question that we just had, but now we need to think about how they relate to parallel. Right, so remember, parallel lines have the same slope. Okay, so I want to look at my two lines, y equals 2x and then y equals 2x plus 3. Remember, the slope is the number in front of our x. Okay, so are these numbers the same? Yes. Same slope is going to be parallel. Okay, easy enough, right? And then our last example for today is number 11. All numbers that end in 1 are prime numbers. What could be a counterexample? So, remember, we went over counterexamples, and that is just something that disproves a statement. Okay? So, I want to find a counterexample. I want to prove this statement wrong. Okay? So, I'm going to think of different numbers that end in 1. We have 1, 11, 21, 31, 41, 51, 61. Okay, and the list goes on and on. So if we're looking at the numbers that we have, remember, a prime number only is divisible by 1 and itself. Okay, those are its only factors. So 1, we already know, that's just 1. What about 11? 11's factors are 1 and 11. Okay, so that's not going to count. What about 21? We have 1 and 21, and then there's also 3 and 7. So let's try 31. 131, right? 41, again, same, 1 and 41. So in this case, 21 is actually our counterexample because it has factors other than 1 and itself. Okay, so go ahead. You guys are going to work on the odds. Okay, there's an assignment where you can practice the odds for the I do on your own. If you have any questions, send them to me through Schoology, and I'll try to get back to you as soon as I can. If not, I will see you guys Thursday, and we'll go over the rest of the review together. Have a great one. Bye.